Okay, so in this question, we have to solve this system of equations using an inverse matrix. So the first thing we're going to do is rewrite the system of equations using matrices. And this is problem number 39 on 10.3. Okay, so this is what the system would look like as using matrices. And if you don't see it, if you just multiply these two together, row 1, column 1, you get 1 times x minus 2 times y. And then row 2, column 1, you get 2x minus 3y. Alright, so that's what the left side would equal. Alright, and that's what the right side would equal. So now we have this equals that, and that equals that, and there's our original system. So that's how we set it up using matrices. Okay, now if this was like a regular equation like this, like 2 times x equals 8, and we have to get x alone, we could just divide both sides by 2. Get x alone, and you get x is 4. Okay, in this case, although this is our unknown, these two variables, and they're being multiplied by another matrix, we cannot divide by matrices. That's not an operation with matrices. So instead, what we're going to do is if we call this matrix A and that matrix B, and this right here matrix Y, what we're going to do is find the inverse of this matrix A, and then multiply that on the left side of both equations, because a matrix times its inverse will just cancel out because it equals the identity, and any matrix times the identity will just equal itself. Alright, so the first thing we're going to do is find the inverse of this matrix. Okay, so the inverse is 1 over the determinant. So the determinant of this matrix would be 1 times negative 3, so A times D is negative 3, minus B times D, so minus negative 4, which is really like a plus 4, which is really like 1 over 1. So this part, the 1 over the determinant, just equals 1, so it doesn't really do anything. Alright, then we're going to switch A and D. We're going to put the negative 3 there and the 1 there, and then negate B and C. So make that negative 2 a positive 2, and make that positive 2 a negative 2. Alright, and we're going to do that on both sides. We're also going to multiply the right side by the inverse. Okay, so this matrix here in orange represents the inverse of this matrix. Okay, now if we multiply these two together, it's going to equal the identity, because any matrix times its inverse is going to equal the identity. And if you don't believe me, try it. If you do negative 3 and 2 times 1 and 2, you get negative 3 plus 4, which is 1. And then if you do negative 3 and 2 times negative 2 and negative 3, you get 6 plus negative 6, which is 0. Alright, and you can keep doing that. Alright, so then we get the identity times x and y equals these two matrices. Multiply them together. So row 1, column 1, you get negative 15 plus 20. Okay, and then do row 2, column 1, you get negative 10 plus 10. Okay, now finally we finish it off. This over here, when you multiply these together, it's just going to equal x and y, because you get x times 1 plus y times 0, and then 0 times x plus 1 times y, so you get x and y, equals, when you simplify this here, you get 5 and 0. So again, could you have solved the system by using elimination or the calculator? Yes, and you got the same answer as this. This is how we solve it with matrices. Alright, so x is equal to 5 and y is equal to 0.